Welcome to AP Help. Today we will be going over AP Statistics Topic 1.5, representing a quantitative variable with graphs. To start with, a discrete variable can take on a countable number of values. The number of values may be finite or countably infinite. Broken down, this says that a discrete variable has gaps. Because it has gaps, there are not infinite values in between two of the possible values that could come from the variable. Because of that, you can count how many possible values there are, but you may have to count to infinity. An example of a discrete variable is rolling a dice. You can only get 6 values, and there are no possible values to get in between those 6. You can't roll 1.5 on a dice. There are gaps in the possible outcomes. Another example is counting the number of customers at a store. There is an infinite number of possibilities, but there are gaps. You can't have 3.5 people at a store. You can count the number of possibilities, but there is no upper bound. Next, you need to know that a continuous variable can take on infinitely many values, but those values cannot be counted. No matter how small the interval between two values of a continuous variable, it is always possible to determine another value between them. Simply, this means that there are no gaps in between the possible values. An example of a continuous variable is the height of a person. You can record the height with as many decimal points as possible. For example, you can have a height of 132.2 centimeters, 132.23 centimeters, etc. You cannot count the number of possible heights. The next thing you need to know is that in a histogram, the height of each bar shows the number or proportion of observations that fall within the interval corresponding to that bar. The histograms at the bottom have the number and proportions of each of the possible values in a given interval. The next thing you need to know is that altering the interval widths can change the appearance of the histogram. As you can see, the histogram to the right has shorter intervals than the histogram to the left, and the histograms look very different. The next thing that you need to know is that in a stem and leaf plot, each data value is split into a stem, which is the first digit or digits, and a leaf, which is usually the last digit. Sometimes, these rules change, so on the AP, if you get a question about stem and leaf plot, remember to look for a legend. The next thing you need to know is that a dot plot represents each observation by a dot, with the position on the horizontal axis corresponding to the data value of that observation, with nearly identical values stacked on top of each other. On the bottom, you see a dot plot from the data to the left. Next, you need to know that a cumulative graph represents the number or proportion of a data set less than or equal to a given number. As you can see, on the bottom, we see a cumulative graph where each bar represents the proportion of values that are less than or equal to the value. Finally, you need to know that there are many additional ways to graphically represent distributions of quantitative data. Some examples are line graphs and box plots. Thank you for watching.